lessons in Chapter 7, we have learned about linear systems in two variables that have exactly one solution. However, in the chart below that is showing graphs, we can visibly see that there are other solutions for linear systems. There could be no solutions, or there could also be infinitely many solutions. In order to find the solutions, we need to look at the approach for solving. There are two different methods. The first method we're going to look at is graphing. We remember and practiced in Chapter 6 that we need to rewrite each equation in a slope-intercept form to make the easiest graph. As we graph the linear system here, we can see that these two equations create parallel lines, and as shown on the last screen, when there are parallel lines, there are no solutions. There is also a way to see this even if you do not create a graph. Notice on these two equations that their slope is the same. Both of these lines have a slope of -2. However, their y-intercept, or b, are different. That means they will be different lines, but again, we learned this in Chapter 5, when they have the same slopes, they are parallel lines. Another method would be to substitute. Because equation 2 can be revised to y equals -2x plus 1, you can substitute -2x plus 1 for y in the first equation. So, when we do that, the variables you are left with are a statement that is not true. However, I did just notice this should be 2x, -2x plus y. We end up with 2x plus a -2x eliminates our variables, and 1 does not equal 5. This tells you there are no solutions. This study tip is listed on your form so that you can have it in your notes. I want to point out a few things. Different slopes, one solution. Same slopes, but different y-intercepts, no solution. That was the parallel lines we just spoke about. And same slopes and the same y-intercepts, that would make infinitely many solutions. So this one is the one we mentioned about the infinitely many solutions. Is it show that the linear system has infinitely many solutions? We have two equations. And the first thing is, if we are going to graph, we want to put them in slope-intercept form. So the first equation changes to y equals 2x plus 3. This was easy because our y had a coefficient of 1, so we can just do our sign changes if we'd like to as they go to the other side of the river, or the equal sign. The second one, however, has 2y as the variable. So after we rearrange the terms, we then would have to divide both sides using balanced equation by 2. When you do so, you will notice we have exactly the same equations. Both equations have the same slope. Both equations have the same y-intercept, or 3. That creates the same line, and all of the points on that line would have the would satisfy for a solution. Now again, going with the method number 2, we're going to use one of our solving or written solutions, and we are plans. And this time we're going to try linear combinations. Again, as talked about in the previous lesson, we chose linear combinations because we have coefficients that could easily be made opposite of each other. So we have a -4x here, and we have a -2x here. What I'm going to do is I'm going to multiply equation 1 by a -2, resulting in this equation right here. The top equation now changed to, over here I'll show you with distributing, Negative 2 times negative 2x is where I got my positive 4x. Negative 2 times a positive y is where I got my negative 2y. And then negative 2 times 3, because I need to do that to both sides of my equation, balanced equation. So 3 times negative 2 gives me my negative 6. By doing so, a variable is eliminated, and you are left with the statement that is true regardless. I'm sorry, our positive 2y and our negative 2y is also eliminated. So we are left with a statement that is true regardless of the values of x and y. This tells you that the linear system has infinitely many solutions. Do notice in example 2 that the negative 2x plus y equals 3 can be transformed to look exactly like negative 4x plus 2y equals 6 by multiplying by 2. The two equations are equivalent. That is why your result is 0 equals 0. Now in example 3, again, we're going to go ahead and we're going to identify the number of solutions. This time it's to solve the systems and interpret the results. You'll notice there is no graphing over here, so we have to figure this out by our written or calculated methods. So we have 3x, negative 9x, we have positive y, and negative 3y. I notice in the first equation I have a single variable, the coefficient of 1, so substitution will be my plan. I'm going to change equation 1 to a y equals equation. Then I will take that and I will substitute it in equation 2 for my y. When I do this, I achieve only one variable. We have our negative 9x, we have our positive 9x, and these are opposites, so they will cancel out. Now I have the true statement, 3 equals 3. And if 3 equals 3, we can say that the equation has infinitely many solutions. The next one, again, we're not going to use a graph, but the first thing I notice is that the equations, when I rewrite them, and this time I rewrote them in standard form because we are not going to use the graphing strategy. So when I change them to standard form, I'm going to notice the 2x minus 2x is going to cancel each other out. The negative 4y and the positive 4y will also cancel each other out. And so 10 will not equal 2, so this one is going to be a no solution. We have nothing to solve for. Okay, where did I get the 2x minus 4y equals 10? Because I saw that we could easily find two equations that could have opposite coefficients, I multiplied this first equation by 2. In doing so, I eliminated both of my variables. That would be the approach of using linear combinations. And our last one that we're going to practice on, solve the system and interpret the results again. So first I'm going to analyze. I see that in this, I again have a single variable. So substitution is my easiest bet. I'm going to change equation 1 to solve it for that single variable y. Once I have that, I will substitute that in to the second equation where the y variable was, giving me the same variables here, or the like terms, so I can change that to 8x. I have a negative 8, that's going to go over on the other side of the equal sign with its constant term 0, creating a positive 8. And then I can divide both sides by 8 using balanced equation to solve for a single variable 1. Remember, the last step is going to be that I'm going to substitute in x, the value of x, the numeric value of x, into one of the equations. You can choose either one. I chose equation 1 because of the positive or adding operation. So 2 times 1 is 2. 2 plus y would equal 4. This is actual mental math as well. 2 plus what number would equal 4? Y equals 2. Then we would also use that coordinate point 1, 2, and substitute that back in for the other equation. That could be a mental math step, and make sure that that also creates a true statement. That concludes the lesson for 7.5.